I'm very happy to announce the next speaker, here to talk about one of our main topics of the day, the supply situation. He is representing a true giant in the market, and as CEO of Hitachi, he knows very well both the possibilities and the challenges going forward to facilitate the green transition. Herzlich willkommen, Andreas Schierenbeck.
Yeah, hello everybody, and thanks for the invitation and nice announcement. It's a pleasure and an honor to be here to address you as one of our biggest and important customers, how we see the world as supplier. And I think it's clear that we understand that the world is changing in multi-dimensions. We heard from the general, from a security perspective, we heard from climate change in Baku, a lot of things are changing. And on top of that change is, I think we are standing at the beginning of a new age of electricity. That's not my own conviction and opinion. I think everybody says that because we see first time since maybe 15, 20 years, things are changing in the electricity market. And that's coming after a period for 15, 20 years where the discussion in my industry was which factory we are closing next, because there was no demand. And now coming in an area of growth. But in this growth area, I think the challenges and the constraints are still the same, they are just more pronounced. Of course, we have to reduce carbon emissions from the point of sustainability. We have to look at secure energy supply from a technical point and from a political point, as we heard today as well. And we have to meet the increased demand. And of course, all of that has to be affordable, as we heard the minister. To balancing these three things, it's actually your business and our obligation to provide the tools and the products and solutions for that. But that's not an easy task. But let's try to declutter it a little bit. If you drive to reduce carbon emissions, it leads definitely to one thing. It leads to electrification. A lot of processes in industry today can be decarbonized by electrifying them by using green electrons. And we're talking about electric vehicles, we are talking about transportation, heat processes sometimes. We're talking about data center, and we will come to that. So there are a lot of things which can be done. Of course, I would guess around 80% of our industries can be decarbonized by being electrified. There is still room for 20% where this is not working, where we need maybe green molecules. If you produce jet fuel, you need additional molecules of hydrogen. For some chemical processes, you need hydrogen. For extreme heats, it's something you cannot really electrify. So there's the room for 20% of hydrogen. And I think, from my conviction, electrification with renewables and molecules works very well together, even if that takes it a bit longer to develop, as we maybe assume. But talking about the timeline, I think our processes in our industries are normally taking a lot of time. Whatever you want to build, it takes a while. Unfortunately, the planning time from the regulator for the utilities was in the same ballpark range like the project. If you build a high voltage line, it takes 8 years, and the planning horizon is 10 years. That doesn't fit. We as engineers know that these time frames are not compatible, especially not if you have to increase the demand dramatically. And you see one trend that regulators across the board expanding the planning cycle for utilities dramatically from 10 to 15 years, or in the US, even to 20 years. Which is good for us in the industry because it gives us visibility about your CapEx, and we heard some numbers already today. Huge numbers, because this is definitely a change, but it shows that the game is on. Of course, the solution for the increased demand is maybe rather simple today because it's the first time that we can say adding renewable generation capacity is the cheapest and actually the fastest way to add electrical energy to the system. Depending on red tape and permitting, you can rather fast building solar or onshore wind. Next thing would be probably SMRs, maybe 7 to 10 years. I think we can all rule out building nuclear very fast. If I say 15 years, that's very optimistic. Most of these projects starting with 15 years and ending up with quite a lot more. You could talk about gas capacity, gas turbines, but the capacities are booked until mid of 30. So if you want to order a gas turbine, good luck. And of course, we could add maybe hydro capacity, but that takes quite a long time as well. So renewables, adding them is the name of the game. But of course, we all know that normally we try to generate where the demand is to not have too much grid. Now this is changing because now we're generating, and you see the green bubbles on the landscape, UK and Ireland, there's a big distance between the demand centers and where the load is, the energy is generated, which is adding on a completely new game, because this distance is something we have to address. So we're adding volatility, because the wind is not always blowing, the sun is not always shining, and we're adding distance we have to bridge. Well, and all of that is hopefully fulfilling the demand. And what you see in Norway is actually what I would say is the peak of the iceberg, because here in Norway you can proudly say already nearly 1/3 of all cars on the streets are electric, which is a huge achievement. You have the charging infrastructure. Nearly all of new sold cars in Norway are electric, 94–95%. This is something which will turn around the installed base dramatically in the next couple of years. Even in households and heating, you have already quite a number of heat pumps, 600 heat pumps out of 1,000 flats or houses, which is quite a game changer. But this will drive the demand for electrical energy even further. You know, we're not really thinking about that charging one Tesla or one BYD with 60 or 100 kilowatt hours. That's multiple times what a normal household normally would use on electrical energy over a year, just with one charge. So, you know, this is completely changing the game. And something what we have completely overlooked as an industry, I would say probably all of us, is data center. Data center was not on the radar. As I was running utility, data center didn't concern me. It's 10, 20 megawatts, who cares, it's easy. Now we are talking about data centers, 500 megawatts, a gigawatts, multiples. And the sheer number of them is driving up demand all over the scope. And you see on the left side, doubling or tripling the global electricity demand for data center is something. In the US, it's estimated that data center will go from 2 to 3% of the global demand in the US to 8 to 12% probably. And that's rather fast, because this industry is fueled by a complete different type of industry, which is cash rich, and they are just building. And they don't care so much about energy prices neither. They're just starting up a nuclear plant, which was down for 4 years, because it was not competitive in the market. So if you pay these prices, you know what is coming. And of course, data center has another spin to it. Normal data centers are running a flat load, fine, you can deal with that. But now we're talking Gen AI. The new data centers are Gen AI, they are even bigger. And of course, 2 things maybe to add. First of all, if you ask Google about something, it's one thing. If you ask ChatGPT about the same thing, it's using 10 times more energy than Google. And Gen AI is getting used. You know, whoever of you have kids in university knows that Google is out, ChatGPT is into writing exams and whatever, and then get the filters adapted that nobody finds out. This thing is out, and it will change our industry because it is there. On the other hand, data centers have a very nasty behavior for utilities. Nobody knows when they start learning, but when they start learning, they're going up from 0 to 200, 250 megawatts, and if they stop learning, they're going back to 0, and sometimes even that in 15 minutes or less. If every customer of you as a utility would do that and show such a behavior, you would have honest talk with them. This is daily business for data center, and to deal with that is a complete different animal. And of course, with renewables, we are talking about the volatility. You know, this is a famous duck curve out of Germany. I think everything has changed completely. The peak at midday is now actually where you get the cheapest prices. You know, renewables are producing quite a lot, and you have to deal with that. We have to add storage systems to that. We have to integrate them on a transportation level, on the distribution level. We have to learn how to do that. We have to expand probably the life cycle of storage on that. And from my point of view, I have to say long-term storage is still not solved. Because with the battery prices we have at the moment, we cannot store energy in an affordable way for days or even weeks. And whatever we have done in the last years, and we heard some numbers, was not enough, because the grid now is a restraining factor. Not only because we talked in Baku about it, that we say, look, we have to triple the investment in grids. The grid is at the moment the bottleneck. We have in Europe 900 gigawatts of ready developed projects of renewables which don't get a license to connect because the grid is not there to take that load. There's big numbers, and sometimes very small areas. And not connecting it means they are not built. And if they're not built, they're not generating. And even the assets we have are constrained. So if the net is not able to transport all the loads, you have curtailment, and the curtailment costs in Europe are 9 billion. And just to shed some light on that curtailment, and I hope I'm not trying to educate you here and you know it better, curtailment means if you have a line between A and B, and A is producing and B is consuming, and the line cannot take it, you tell the asset on A, shut your assets down, your windmills, you're getting paid, don't worry. You're spending money for not producing, and we're ramping up an asset on near B and paying for that as well to deliver the energy which we cannot transport. So we are wasting economical resources. 9 billion is a lot of money. We can build a lot of things with that. And we have to start to building that, because this problem will become bigger and bigger. It will not go away. And with renewables, we're getting now the challenge of geographical distance. We all learned as engineers, don't transport electrical energy too far, make it very short, generate where you consume. Grid is a safety network, and so on. But if you want to transport electrical energy over long distances, we have a technology since 70 years, invented in Sweden. High voltage direct current transmission, low losses, has a lot of advantages by connecting grids, because you have no problem with frequencies at all. And it was the first installation in 1954. And since 1954, we know how to do it, but it hasn't really kicked off until now. Because if you look now, and if you're going from left to right, one connection in the 50s, 60s, then you have a couple of more, and on the very right side, you see what we have and what is actually in planning. 50 planned for the next 10 years, 30 already there. You see this one is really exploding. And exploding means we have to produce it. You can imagine these installations, like all the products we have, haven't been sought after in the last 10, 15 years. And now suddenly we have to do it. And yes, we come to CapEx and how we're doing it, but this calls now for something new. I think for a better collaboration between producers and customers, because to keep up with that scope, we have to talk about standardization. And I mean not only standardization on single equipment, across the industry as well. You see here an offshore platform from Statnetts. Statnetts has standardized their offshore platform for all 3 HVDC suppliers, so GE, Siemens, and us. So whatever you put in as a customer, you get the same offshore platform. And this is taking a lot of tons of steel out of the process and a lot of money and time, because otherwise it would have been designed purposely for this project according to that specification, long lead times. And there's no way to cope with that without standardization. So that's the first step. The second step is you have to go from projects to programs. Actually, we need a pipeline to invest. We have to know what is coming to order the long lead items. So actually, in the market, we see that customers signing up on framework agreements and capacity reservations say, look, I'm buying 3, 4, 5, 6 projects from you in a competitive way and indexed. It's all good. But you know what is coming, and you can prepare for that. You can book the slots, you can build the assets, you can order the long lead items, and we're getting faster and we're taking costs out. And if you're talking about CapEx, we are investing quite a lot. We have already invested 3 billion in the last 3 years. We are investing actually now 1.5 billion only in expansion of transformer capacity, and a couple of billions in the remaining of the business. But if you think that you can now buy a transformer for us, sorry, it's all booked, it's all reserved. We're not building capacity which is not booked or reserved or bought, because everybody is afraid after 15 years closing factories that we are building overcapacity. And the 3 years we need to build it and train the people are maybe enough to fall in a hole, and everybody's saying, look, you're just building the next problem for tomorrow. So we have to find a way how we really coming together in a collaboration with our customers from a transactional point of view to a framework agreement, to a strategic point of view, that we know what you need and when, and we can come together to build that. We are not low on CapEx. I can spend even more. It's not a problem. I'm constrained by people, because I have to train them. I'm constrained by machines I have to buy. But I need the offtake guaranteed in a way that we can manage the risk jointly. And there's another thing what we have to do. If I look at the projects we are driving, we are spending a lot of time on permitting and licensing. Actually, normally 2/3 of the time for a project of that is red tape. And only 1/3 is building. I brought you one example out of Germany, Südlink, very famous one, because Germany switched from overhead voltage lines to cables, delayed the process a little bit, but you see here 7 years of planning, because the whole cable link was distributed in 15 segments of around 40 to 50 kilometers with their own permitting process in different jurisdictions, different paperwork for the same cable, by the way, took forever and cost money. And I think we can save here much more time than we think. And with that, we have the time to cut the timeline and save cost, because permitting and that, I don't have to tell you, that's expensive. So actually, to come to a conclusion, I believe that we as an industry, we have actually the right answers. We know that we can build renewables. We know that we can take the challenges on. We have the technology we need. I think what is needed, actually, that we come to a new way of working together as customers and industry, from a transactional point of view to framework to strategic, cut the supply chain as short as we can, saving cost with that. And I think we have to talk with the regulators how we can really reduce the red tape for that in licensing and permitting. And with that, I would think the future is green. It will be a lot of work together. I'm looking forward to take on that challenge with you, but I'm not concerned. Thank you very much.